Hi, hello dear students, welcome to our channel Maths with Panindra. In this video, we are going to discuss probability. We are in exercise 9b in the second section. In the second section, first question. So, what is the first question here? A pair of dice are rolled 24 times. A person wins by not getting a pair of sixes on any of 24 rolls. What is the probability of his winning? What is the probability of his winning? This is the question. Here the question is, a person wins by not getting a pair of sixes. We know that in the previous classes I discussed that a dice, one die if you throw, you will get 1, 2, 3, 4, 5, 6. Any one of the number, it will appear on the upper face. If you throw a die twice, that means 2 dice at a time if you throw. These are the possibilities we are going to get. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Like this 2, 1, 2, 2 and so on. 6, 1, 6, 2, 6, 3 and so on. 6, 6. So like this 2 dice, that means pair of dice they are saying. So pair of dice if you throw, you will get 36 possibilities. So first n of s you have to write it. A pair of dice. In the solution tab, a pair of dice are rolled 24 times. Here only observe carefully, dear students. Then the total outcomes. Or see 36 outcomes you are getting now. Pair of dice are rolled 36. So n of s equal to total possibilities. Pair of dice rolled how many times? 24 times. If the pair of dice, one time if you throw a pair of dice, you are getting 36. This is only one time. If we do twice, 36 into 36. If we do thrice, 36 into 36. If you do 24 times, 24 times. So it will becomes, so 3 into 3 into 3, 4 times means 3 power 4 we will write it. Similarly, 36 into 36 into 36 into 24 times. So n of s is equal to 36 whole power 24. I hope you people understand that. This is total number of possibilities. That's the first one. Now come to the required. A person wins by not getting a pair of 6. Here how many pair of 6 are there? Only 6, 6. Observe dear students, here only 1, 6, 6 is there. So except this one, what are the possibilities? 35 possibilities are there. Total 36. In that, the person wins by not getting the 6, 6. A pair of 6s. So, we can eliminate 6, 6. The required 35 possibilities will come when a pair of dice are rolled. So, here, event you can take it. Let E be the event. E be the event that a person wins by not getting a pair of 6 or a pair 6s on any 24 rolls. So 24 times they are rolling now the dice. So that is n of e is equal to how many possibilities we are getting. In these 36, they are asking that not getting a pair of sixes, not getting a pair of sixes out of 36. Out of 36, we are not getting 6, 6. So other than 6, 6, remaining 35 possibilities are there. Therefore, 35 into 35 into 35, like this, how many times they are rolling? 24 times. So n of e is equal to 35 whole power 24. Therefore, the required probability of an event is P of E is equal to N of E by N of S. So N of E value we have, N of S value we have, substitute. So N of E value is 35 whole power 24 by N of S value 36 whole power 24. That can be written as 35 by 36 whole power 24. These are the total number of required probability. The person wins by not getting the pair of sixes. We'll move on to the next question, dear students. Yeah, dear students, next question. If P is a probability function, then show that for any two events A and B, P of A intersection B is less than or equal to P of A is less than or equal to P of A union B is less than or equal to P of A plus P of B. See, for this we need to draw the Venn diagram according to the question. This is A, this is B. Obviously, this is A intersection B, the common part of A and B. A comma B, A and B are any two events in the sample space, no need to mention here. These are any two events and P is the probability function. From the figure, we observe that the common part A is intersection B is less than A. From Venn diagram, A intersection B is less than or equal to A is less than or equal to A union B. A union B means the common value, the union of these two sets A and B. So taking P as the probability function is given. So taking probability P of A intersection B is less than or equal to P of A is less than or equal to P of A union B. You put that equation number 1. From axiom of unity, union, from axiom of union, we have P of A union B equal to P of A plus P of B. So we can write it as P of A union B as P of A union B is less than or equal to P of A plus P of B. We can write it by using axiom of union. Equation number 2. From 1 and 2, P of A union B is obviously less than. From 1 and 2, P of A intersection B is less than or equal to P of A is less than or equal to P of A union B, which is also less than or equal to P of A plus P of B. Hence, the result. What they are asking to prove, we got it now. Only from set theory and probability function. Here, axiom of probability, axiom of union, probability axioms I discussed in the last video. Please, dear students, once you go through that video, 3 important points I discussed. One is certainty, axiom of union, and addition theorem of probability. These information I have given in the previous video. Please look into that video. We will move on to the question number 3. Next question, dear students. Third question. A box containing 15 bulbs, 5 are defective. If 5 bulbs are selected at random from the box, find the probability of the event that. First question. None of them is defective. Only one of them is defective. At least one of them is defective. In this total 3 questions, first question, third question has relation. Observe carefully, dear students. First question and last question are having the relation. Here, none of them is defective. No bulb is defective here. None of them is defective. So, all are good only, no? Here, at least one of them is defective. That means, at least one of them means either one bulb is defective or 2 bulbs is defective. Total how many defective bulbs are there? 5 are there. So, it will be reverse of this one. So, after getting none of them is defective, some value will come, no? The probability. If you want to get at least one of them is defective, 1 minus of this one, complementary event, if you take it, it will come that answer. So, complementary event. Like this way, you should get it answer. So, the relation between these two you remember, keep in mind, anyway I will explain. So, first the box containing 15 bulbs, the total number of bulbs, total number of bulbs, NO means here line is there means number of bulbs, 15 bulbs are there. In that 15, 5 are defective. Defective bulbs. That means the rest of the 10 bulbs are good bulbs only, no? Good bulbs means non-defective. Good bulbs or non-defective bulbs. They are defective, this is non-defective. So, first question, before going to do that first question, the total number of possibilities we need to write that sample space. So, in the sample space, total 15 bulbs are there. How many bulbs we have to select? See here, if 5 bulbs are selected at random, so 5 bulbs are selected at random from 15. No need to write from 15. 5 bulbs we need to select. 5 bulbs are selected at random. Then N of S is equal to total possibilities which are out of 15 we have to select 5 bulbs in 15 C5 ways. 15 C5 selecting the things. 15 C5. These are the total possibilities. Now come to the question number 1. None of them is defective. None of them is defective. So what are the defective bulbs here? Sorry, none of them is defective is good bulbs. So question is none of them is defective. Side heading. we need to select 5 bulbs. How many good bulbs are there? None of them is defective means good bulbs are 10. Out of 10 bulbs, how many bulbs you have to select? 5. So, let A be the event of selecting. Let A be the event of selecting the bulb. Selecting the bulbs from non-defective. That is, N of A is equal to how many non-defective bulbs are there? 10 non-defective bulbs are there. So from 10 we have to select 5. 10C5. Therefore, the probability of A is equal to the probability of none of them is defective. The probability of the event of selecting the bulbs, none of them is selected, is N of A is by N of S. N of A is 10C5 by 15C5. So 10C5 means we can calculate in that way. 10 into 9 into 8 into 7 into 6. 10C5, you know, here 5 is there means from 10 we can decreasing order 5 values we can write it by 1, 2, 3, 4, 5. Whole divided by 15C5 from 15 to 5 numbers decreasing order. 15 into 14 into 13 into 12 into 11 by 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 get cancelled. After that also, here 15 and 10. 5 2s are 5 3s are. Next 3 1s are 3 3s are. Next 4 2s are 4 3s are. 3 1s are 3 2s are. Next 7 1s 7 2s here also. So 4 into 3 12. 12 by 13 into 11. So 12 by 13 into 11 is 12 divided by 143. I hope not able to see now. Please. Yeah, you are not able to see here. From here I will write it. So after simplifying this, otherwise here I will simplify clearly. So it will become P of A. P of A is equal to 10C5 divided by 15C5. 10C5 means from 10 into 9 into 8 into 7 into 6 by 1 into 2 into 3 into 4 into 5 by 15C5, even from 15 also, 15 into 14 into 13 into 12 into 11 by 1, 2, 3, 4, 5. So you can cancel 1, 2, 3, 4, 5. 6 1s are 6 2s are. 2 1s are 2 4s are. 5 3s are 5 2s are. 3 1s 3 3s. Next here 7 into 2 14, here 14. So 3 4s are 12 divided by 13 into 11, 143. So P of A is equal to 12 by 143. So this is the, none of them is defective. So 5 are defective, 10 are non-defective, that means good bulbs. So to get the probability of none of them is defective is, out of 10 you have to select any 5, 10C5 by total possibilities 15C5. Come to the third question directly. I am not writing that second question. Observe dear students. A be the event of selecting bulbs from non-defective. But the question of third question is at least one of them is defective. One of them is defective. At least one of them is defective means Either 1 is defective or 2 or 3 or 4 or 5. 5 also defective. So let A complement be the event that let A complement be the event that let A complement be the event that none of at least one of them is defective. At least one of them is defective. That is equal to at least one of them is defective is equal to 1 minus none of them is defective. That is the probability of, so P of A complement is equal to, by using complementary property, P of A complement is 1 minus P of A. That is equal to 1 minus, don't write directly, what is P of A meaning? 1 minus, none of them is defective. None of them is defective. Probability of none of them is defective. So 1 minus probability of none of them defective is what? P of A value 12 by 143. So which is equal to 143 LCM. 143 minus 12, which is equal to 131 divided by 143. So, Roman 3 question. None of them defective. First question. At least one of them is defective means 1 minus none of them is defective. Dear students, wherever like this situation is there, you need to calculate in that way. It's a very simple question. I hope you people understand that. Whenever like this situation is there, at least one of them is defective. So it should be equal to 1 minus probability of none of them is defective. So we'll move to the second question. Only one of them is defective. I am going to tell that. See here, dear students, none of them is defective, no? Sorry. Yes, only one of them. Only, this is the second one, not the third one. Only one of them is defective. How many defective bulbs are there? How many good bulbs are there? Here one of them is defective. So 5 defective bulbs, 10 non-defective, that means good bulbs. So we need to select 5 bulbs compulsory. 5 bulbs we need to select. One of them is defective. So from 5 you can select one bulb in 5C1 ways and means into. The rest of the 4 compulsory, it is coming from non-defect only. So only one of them is defective. Only one of them is defective means total 5 defective bulbs are there. From that 5 we can select 5C1 and the remaining 4 bulbs we can select from 10. So 10C4. Therefore, E be the event that one of them is defective. One of them is defective. Therefore, N of E equal to 5C1 into 10C4. This is N of E. N of S already we have that 15C5. So, N of S, the probability P of E is equal to N of E by N of S. N of E 5C1 into 10C4 by 15C5. N of S value 15C5. You can simplify 5C1 into 10C4 by 15C5. 5C1 means 5. 10C4 from 10 decreasing order 4 times. 10 into 9 into 8 into 7 by 1 into 2 into 3 into 4 by 15C5 from 15 decreasing order 5. 15 into 14 into 13 into 12 into 11 by 1 into 2 into 3 into 4 into 5. So from this calculation these 4 will be cancelled. So 5 ones are 5 threes are. So in the numerator 5 into the terms I am writing 10 into 9 into 8 into 7 whole divided by 3 into 14 into 13 into 12 into 11. So 4 table 4 threes are 4 twos are 3 threes are 9. The cancel that also. Next 7 into 2 14 cancel. So the remaining 10 into 5 15 by 11 into 13 143. Therefore the probability of the event E, one of them is defective, is 50 by 143. I hope you people understand it, students. We will move on to the next question. Question number 4 we will do it. The next question, dear students. A and B are seeking admission into IIT if the probability for A to be selected is 0.5 and that both to be selected is 0.3, is it possible that the probability of B to be selected is 0.9? They are asking whether it is the probability of the person D is to be selected is 0.9. They are asking the question. Whether it is possible or not, we will decide by finding the value. So A and B are seeking admission into IIT. So the probability of these persons getting the seat in the IIT are given. So P of A, given that P of A, what is the meaning of P of A? The probability for A to be selected is 0.5. So given that P of A is equal to 5. Next, and both to be selected is 0.3. Both to be selected. So and also given P of A intersection B is equal to 0.3. P of A intersection B is given as 0.3. The probability of selecting both is A intersection B. Whenever both is there, the intersection of the probability of A intersection B. Next, whether the probability of B is 0.9 or not, we will verify. So for that, what we have to take? By addition theorem on probability, we have P of A union B is equal to P of A plus P of B minus P of A intersection B. We know that axiom of unity and certain unity. A union B is the sample space. So we know that S is equal to A union B. So probability of S is equal to probability of A union B. Probability of S is always 1. So P of A union B is always equal to 1. So sample space. So P of A union B value is 1. P of A value is given as 0.5. But we need to get that whether it is P of B value 0.9 or not. We will verify. That is the reason I am not writing here. Minus P of A intersection B 0.3. So 1 equal to 0.5 minus 0.3, 0.2 plus P of B. From this P of B make it the subject. So P of B is equal to 1 minus 0.2, that is equal to 0.8. P of B equal to. So P of B equal to 0.8 we got it. But 0.9 is possible they are asking. Therefore, the probability of B is selected is not 0.9. That we can do that. Is not 0.9. Why? Because we got it as 0.8 now. So the probability of B is selected is not 0.9. We are giving the conclusion here. Is it possible means? No. The probability of B is selected is not 0.9. We have given here conclusion. I hope you people understand. We will move on to the next question, dear students. Yeah, the next question. This is also very important question, dear students. Make a note. The probability for a contractor to get a road contract is or 2 by 3 and to get building contract is 5 by 9. The probability to get at least one of contracts, that means one contract is 4 by 5. Find the probability to get both the contracts. Here the question is, they are asking to find the probability to get both the contracts. Both means, in the last question also we discussed, both means intersection is given. So the probability of A intersection B we are going to calculate. So the required one is P of A intersection B. But here based on assumption of the events. Here what I am assuming is the probability for a contract to get a road contract. Here I am assuming that P of R is the probability of getting road contract is 2 by 3. So the probability of getting road contract is P of R. Similarly, the probability of getting building contract 5 by 9. This is the first step. The probability of getting building contract P of B represents the probability of getting the building contract. How much it is given? 5 by 9. And the probability to get at least one contract. The meaning of at least, how many contracts are there? Road contract and building contract in this question. At least one of the contracts means either the person will get road contract or building contract, or means union. That means that value is also given. So next, the probability of getting at least one contract is 4 by 5. At least one contract means that is P of probability of or union B, either road contract or building contract. P of R union B is equal to 4 by 5. So P of R, P of B, P of R union B. So they are asking what? Find the probability to get both the contracts. P of R intersection B is required. Probability of R intersection B, road contract and building contract. So by addition theorem on probability, addition theorem on probability, we have P of R union B is equal to P of R plus P of B minus P of R intersection B. So required is P of R intersection B, that becomes the subject. So interchanging the values. Otherwise directly value substitute. P of R union B 4 by 5. P of R 2 by 3 plus P of B 5 by 9 minus P of R intersection B. So from this P of R intersection B is equal to that value we are taking this side. So 2 by 3 plus 5 by 9 minus 4 by 5, which is equal to LCM of 395. How much? 45 we take. So 3 15s, 15 2s are 30 plus 9 5s are 5 into 5, 25 minus 5 9s are 9 into 4, that is 6. So which is equal to 35 minus 36 plus 30 means minus 6. 25 minus 6 is 19. 19 by 45. Therefore, the probability of getting both the contracts or intersection B is equal to 19 by 45, which is the required probability. I hope you people understand, dear students. We'll move on to the next question. The next question, dear students. In a committee of 25 members, each member is proficient either in mathematics or in statistics or in both. If 19 of these are proficient in mathematics, 16 in statistics, find the probability that a person selected from the committee is proficient in both. Here I am assuming that E1, E2. E1 be the event of selecting the person is proficient in mathematics. E1 be the event that selecting a person is proficient in mathematics. So total committee, it contains 25 members are there in this committee. So out of 25, 19 are proficient in mathematics. So from 19 you have to select one person, and from 25 also select one person. The probability of E1 we are going to get this. P of E1 is equal to 19C1 by 25C1. Directly I am writing now. Anyway, 19 by 25. Similarly, E2 also write it. E2 be the event that selecting a person is proficient in statistics. So how many statistics persons are there here? 16 in statistics. So out of 16, one person can be selected, and out of 25 also, one person will be selected. P of E2 is equal to 16C1 by 25C1, that is 16 by 25. So the selecting the probabilities, selecting the person from mathematics and statistics is over. Next, find the probability that a person selected from the committee is proficient in both. In both, the person will be selected. Both means what? E1 intersection E2. So they are asking here, P of E1 intersection E2. This is the question mark. Probability of the event that selecting a person is proficient in both maths and statistics. See, before that, to get this result, in the sample space, yes, E1 and E2 are two events, E1 and E2. So this intersection probability we are going to calculate. So whenever E1, E2 are the two events in the sample space, yes, E1 union E2 is equal to yes. Taking probability on both sides, P of E1 union E2 is equal to P of S. So P of S is certain event, is always equal to 1. Therefore, P of E1 union E2 is equal to 1. After that, after getting this result, by addition theorem on probability, this is the question mark why I kept here. The probability that a person selected from the committee is proficient in both. By addition theorem on probability, addition theorem on probability, we have P of E1 union E2 is equal to P of E1 plus P of E2 minus P of E1 intersection E2. So this is the required value, dear students. E1 intersection E2. So P of E1 E2 value is what? 1. P of E1 value 19 by 25 plus P of E2 value 16 by 25 minus P of E1 intersection E2. That is the required result we are going to calculate. This is the person who is proficient in both. The person is proficient in both categories, in both maths and statistics. So minus P of E1 intersection E2, we can take the sign. P of E1 intersection E2 is equal to, so whenever denominators are same, no, you can add that. 19 plus 16, 35 divided by 25. 1 we are taking this side, minus 1. So 35, take LCM here, 25. 35 minus 25, which is equal to 10 by 25. So 5 2s are 5 5s are. Therefore, the probability of the person who is proficient in both mathematics and statistics is P of E1 intersection E2 is equal to 2 by 5. I hope everyone able to understand these, students. We will move on to the next question. Yeah, the next question, dear students. A, B, C are 3 horses in a race. The probability of A to win the race is twice that of B, and the probability of B is twice that of C, what are the probabilities of A, B, C to win the race? What are the probabilities of A, B, C to win the race? So how to proceed this question? So A, B, C are the three horses now. Capital A, B, C are three horses in a race. So these are the events in the sample space. Here sample space is the race. The probability of A, given that, before that what we have to write is the probabilities of so A, B, C are to win the race. To win the race are P of A, P of B and P of C. After that conditions are given. What conditions are given? The probability of A to win the race is twice the probability of B. Given that P of A is equal to twice that of B. So 2 times of probability of B. P of A is equal to 2 times of P of B. Next, the probability of B is twice that of C. So P of B is equal to twice P of C. But we don't know the probability of C first thing here. P of A in terms of P of B is there. P of B in terms of P of C. But P of C we don't know. So how to do that is P of C is the probability of to win the race by the third horse C. Okay. In the A, B, C are the 3 events now. 3 events means 3 horses. So S be the sample space which is the race. A union B union C is equal to S. Sir, now why you are writing, sir? In the sample space, that means in the race. A, B, C are 3 events. A, B, C, 3 horses which are participating in the race. So the union of these 3 events is the sample space and they are disjoint. A intersection B, B intersection C, C intersection A. There is no link up here. So which are disjoint? A, B, C are disjoint. Disjoint means intersection or disjoint. That is A intersection B equal to B intersection C equal to C intersection A. Not only this one, and A intersection B intersection C is also pi. Null set. If you take these probabilities, all are goes to be 0. So which are, whenever these are null set, intersection, there is no common thing in this. So, but that is the reason taking probability on both sides. P of A union B union C is equal to P of S. P of S, always the probability of the sample space is equal to 1. Certain event, that is equal to 1. What is P of A union B union C? Whenever these are disjoint events, that means mutually exclusive and exhaustive events, by the property of union of axiom of unity. Axiom of unity can be written as P of A plus P of B plus P of C, simply. So that is the reason we are explaining here, we are writing like this. The rest of probability theorem, addition theorem of probability for 3 events, it will come like this. These values goes to be 0. This is for understanding purpose I am writing here, students. These values mutually exclusive and exhaustive events. That is the reason these values goes to be 0. So it will come only P of A plus P of B plus P of C equal to 1. So what is P of A? 2 times of P of B. So P of A, once again I am writing, plus P of B plus P of C is equal to 1 now. We don't know P of C value. So from here, P of B value is 2 times of P of C. No? So 2 times of, in place of P of B, 2 times of P of C. So ultimately it will become 4 times of P of C. Observe carefully, dear students. P of B is 2 times of P of C. So in place of P of B, 2 times of P of C, 2 2s are 4, 4 times of P of C. So P of A is equal to 4 times of P of C. P of B is equal to 2 times of P of C. P of C is P of C only. So now P of A is equal to 4 times of P of C plus P of B value is 2 times of P of C plus P of C is equal to 1. So 4PC plus 2 times of P of C plus P of C. That implies that 7 times of P of C is equal to 1. Therefore, P of C is equal to 1 by 7. So the probability of winning the race by the third horse C is 1 by 7. Whenever you know the value of P of C, you will get P of A and P of B. Therefore, P of A is equal to 4 times of P of C. So 4 times of 1 by 7, that is equal to 4 by 7. Next, P of B is equal to twice of P of C. It is given on twice of P of C. So substitute here 2 times of 1 by 7, that is equal to 2 by 7. So P of B. Therefore, the probabilities of A, B, C are 4 by 7, 2 by 7 and 3 by 7, so 1 by 7. Therefore, the probability of A is 4 by 7, the probability of B is 2 by 7 and the probability of C is 1 by 7. This is the way you can calculate your students. This is some theoretical concept. We need to understand that. I hope you people understand this question. We will move on to the next question. The next question, dear students. Question number 8. A bag contains 12 2 rupees coins. See, this is the bag. 12 2 rupees coins. The 2 rupees. 12 are there. Next, 7 1 rupee coins. 7 are there. Next, 4 half rupee coins. 50 pies. 4 are there. So in a bag, 12 2 rupees coins, 7 1 rupee coins, 4 50 pies. So total how many coins are there? 12 plus 7 plus 4. So 11 plus 12, 23. The total number of coins in a bag. 12 plus 7 plus 4, which is equal to 23. So how many coins we have to select? 3 coins are selected at random. So 3 coins are selected at random from 23. 3 coins are selected from 23 in 23 C3 ways. That means N of S, total number of possibilities 23 C3. 23 C3. These are the total possibilities, total possible outcomes of the experiment. Experiment of drawing 3 coins from the 23 coins. Now come to the first question. The first question is here, the sum of 3 coins is maximum. So the sum of 3 coins is maximum means here among these coins, which coin is having more value? So 2 rupees coin, 1 rupee coin and 50 paise. So among the 3, 2 is more value, no? Compared with these 3. So 2 is having more. So the sum of 3 coins is maximum. To get maximum, the sum of 3 coins is maximum, we have to select the 3 coins from 2 rupees. So here the event, the probability of, directly I am writing, the probability of, before that we can write E1 be the event, E1 be the event that getting the sum of 3 coins, the sum of 3 coins is maximum. The sum of 3 coins is maximum. So, what is maximum here? 2 is maximum value. So, therefore, 3 coins, getting the sum of 3 coins is maximum. So, 3 coins can be selected from 12 2 rupees coins, 12 2 rupee coins in 12 C3 ways. This is n of E1, 12 C3. Therefore, the probability of getting the sum of 3 coins is maximum. Therefore, the probability of getting the sum of 3 coins is the sum of 3 coins is maximum is P of E1 equal to n of E1 by n of S. N of E1 is 12 C3 divided by 23 C3. The first question completed. So 12 C3 by 23 C3. We'll move on to the next question. See here, what is the second question? Roman 2. The sum of 3 coins is minimum. E2 be the, here I will write it, otherwise you won't. E2 be the event. E2 be the event that getting the sum of 3 coins is minimum. The sum of 3 coins is minimum. So what we have to do? So minimum means small. How many? 50 points. 50 paise is the minimum value among these 3. So from 4 50 paise coins we can select 3. So 3 coins can be selected from 3 coins can be selected from 450 paise. 450 paise in 4 C3 ways. So therefore n of E2 is equal to 4C3. So N of E2 is equal to 4C3. So therefore the required probability, no need to write directly I am writing P of E2. If you want to write step for this P of E2, the probability of getting the sum of 3 coins is minimum is P of E2 equal to N of E2 by N of S. N of E2 is 4C3 by N of S is 23C3. So what is the third question here? Each coin is a different value. That means 2 rupees coin, 1 rupee coin, 50 pice. So from 2 rupees coin, 1 we can select. From 1 rupee coin, 1 we can select. And from 50 pice, 1 coin. So Roman letter 3. E3B, the event that getting each coin is different. Each coin is different value. So from 12 2 rupees coin 1, instead of writing all, you can write directly. So N of E equal to, N of E3, third one now, N of E3 equal to. So from 12 2 rupees coin 1 we can select 12C1 and it's into, and from 7 1 rupee coins 1, 7C1, and from 450 pies 1 we can select 4C1. So these are the possibilities. Why? Because each coin is different value they are saying. That means from 2 rupees, 12 2 rupees coins 1, from 7 1 rupee coins 1, from 50 pies 4, 50 pies 1, we can select. Therefore, the required probability P of E3 is equal to N of E3 by N of S. N of E3 means 12C1, 12. 7C1, 7, 4C1, 4 by 23C3. NC1 is equal to N. That is the reason 12C1 is 12, 7C1 is 7, 4C1 is 4. So this is the way we can do, students. This is also one of the important questions. Many chances to come in the boards. I hope you people understand, dear students. You enjoyed this class, I hope. If you have any doubts regarding this session, please write to my comment box. I will help you. Thank you all. Signing off. Maths with Panindra. Jai Hind.